Okay, continuing on with our training for doing reserves evaluation using PHDWin software. The next topic we're going to talk about is operating expenses and understanding those and how they're applied to reserve evaluations. Okay, sometimes we call it Opex, operating expense. But why are these expenses important? Because the operating expenses affect the cash flow and reserve value, because we're doing reserve value based on a future discounted cash flow. So you have to subtract out the expenses to get the cash flow. Also, the operating expenses for each well or field determine the economic limit, because there are no reserves after the economic limit has been reached. So what are operating expenses? They're the normal ongoing cost to operate a well or field. It could be pumpers, field personnel, supplies, water disposal. Sometimes that's a big cost when you have a lot of water production. Compression, chemicals, equipment maintenance. But it also can include normal ongoing well repairs, like pump change outs, tubings, rods, that sort of thing that you do on a normal basis when you're operating a field that has pumping units on it. So that would be included in the operating expense. But it does not include capital expenses such as drilling or recompletions. That's not part of OPEX. And in PHDWin, we do not include production or ad valorem taxes as an operating expense. That's handled separately. And operating expenses can be modeled in your economics projections as fixed or variable, where fixed is dollars per month and variable is dollars per barrel, because as the production goes down, the expenses would go down, or they would vary based on production. So how do we determine operating expenses? Well, the best way is to analyze historical data. But if you don't have historical data, sometimes you can find published data from similar fields or from the operator public reports. And many times, if you have no data, you may just have to estimate the operating expense from your experience, with other fields or projects you've done that were similar, similar type production, production rates, well depths, that sort of thing. You can estimate it. And if possible, we want to estimate the operating expenses on a per well basis, and we usually categorize it as dollars per month operating expense. All right, so fixed versus variable, we mentioned that. If we model all expenses as fixed, we will get lower reserves and value, and that's conservative. It could be conservative. But if we model all expenses as variable, we get higher reserves and value, and that is optimistic. All right, here's some example of fixed and variable expenses. The fixed is on the left. So we have a cash flow, money on the left versus years at the bottom. And we have all production in green and revenue in red. And we have actual data to the left, and then we're going to project into the future, these items. So the fixed operating expense is in black. So it's constant. So as the production goes down and the revenue goes down, the cash flow goes down, because the cash flow is just the revenue minus expenses. So when the revenue falls below the operating expense, the well is no longer economic. So the economic limit in this case was reached after 9.5 years. But if you use a variable OPEX method that's shown in the right with the same data, that variable OPEX goes down as the production goes down. So that extends the economic limit out further to 12 years. Plus this little wedge of money and revenue is added. So you have more reserves and more value. So the fixed is lower reserves and value, and the variable is more and optimistic. All right, so how do we determine? We said the best way is to look at historical data. Here's some historical data from 2 wells. So we have about 12 months of data, And we have different categories of expenses, and the amount that they're spending and the total for the month of well 1 is listed here at the bottom. So you have to look at that and make sure it looks constant and consistent. But in this case, you can just average up all the months, and for well 1, we could use $4,419 per month operating expense in your economic projections for that well when you're doing reserves on well 1. Now, well 2 is at the bottom. Its expenses are a little bit higher, about double. It has maybe more fluids that they have to handle or more repairs. Anyway, the number 2 well, we would use $8,610 per month operating expense. And we do this, we use these type of values all the time. Even it is a fixed amount, but if we have many wells in a field, as the wells become economic, they would drop out. So is somewhat of a, has some variable to it. But anyway, this is common to use these type of techniques when you have individual well data. All right, this next example is historical operating expense data on a field level. So sometimes the operator doesn't report the expenses by well, they just have it by lease or field. And right here we have about 10 months of data, but we know there's 5 producing wells in this field. So we have to look at the data, analyze it, see what it's telling us. We can look at the different items. Contract labor seems to be a big number, per month. The compressor expense is a pretty big number. So we have to look at that, analyze it. But you can add up all the numbers, and at the bottom, the monthly totals are at the bottom. And the average is about $52,500 a month for the field. So if we know there's 5 wells, we could divide that by 5. And we could say as a fixed amount, each well takes $10,504 per month to operate. So that would be a fixed analysis. And we could apply $10,000 per month to each well or in the economics. Or we could look at the production data. So over here in green, you can see how much the production is each month. So if we want to get a variable cost, we could just divide the production each month by the operating expense each month by the number of barrels, and we get an average of $13.50 per barrel. So that would be a variable cost. So we could either use the $52,000 or the $13.50. But in most cases, we wouldn't want to use either one of these to get a more accurate picture of how the field is going to perform. So in this case, we add some more data to the spreadsheet, and we make a fixed and variable column with fractions. And we try to estimate, based on our experience, what portion of these expense items would be fixed and variable. For instance, the compressor expense, we're using 50% fixed and 50% variable, because as the production goes down, you could get rid of some of the compressors and that expense would go down, but you're probably going to always have at least one in the field, so it's not 100% variable. So we estimate these fractions for each of the types of expense based on our experience, and we multiply these factors and we get some new columns to the right and total those up. So the fixed expenses are about $28,000 a month, and the variable are about $24,000. So that's about 50-50 split. That's usually pretty conservative and good. You don't want to go 80-20 unless it warrants. All right, so now we have 2 new numbers, 28,000 and 24,000. If we divide the 28,392 by 5 wells, we will get a fixed amount per well. And if we divide the 24,127 by the amount of barrels produced each month, we'll get a variable share. So basically this is a combination method. And so what we would get is we would get the $5,600 per well variable plus the $621 per barrel. $5,600 per month per well and $621 per barrel. So anyway, that would be like a hybrid method where you kind of do partial fixed and partial variable, and that would be probably better. You have to use your judgment when you're doing reserves, but it's very important because you can extend the life of the field and increase the value of the field by changing those numbers. Okay, so let's see how you input operating expenses into PHDWin. So let's go back to our project. Here's our case list, and we have some wells we want to evaluate. So we're going to go to operating expense tab. So it's empty. So we can put well cost or just fixed lease cost or so much per barrel or MCF. So let's go ahead and click on there, and we can say, all right, we can change these dates or do it as the as of date and different things, but you can put in a cost. So like this would be $5,600 per month. And maybe, you know, if we want to, we can say, well, for the first 12 months, it would be that, and then press insert. Then maybe, you know, after they get all the flow back and everything, expenses might only go to $4,000 a month, and you can do that to the economic limit. So that's kind of a little, you can model it like that. And you say, well, we also know that we have a variable cost of $1.50 a barrel. So you can put that in. And you can save this as a model and apply it to all the wells. Or if you want to do some global editors, you can do it like this. So you go global editor, and you pick your wells you want to edit, and you go to expenses. And if you have a model set up with that stair step, you can apply it. But in this case, let's just show you how to do you just use a force value. That's the simplest way. So you can come in here and say well cost or fixed cost. If you have one well on the lease, you know, fixed and well cost is the same. But if you have multiple wells, you can project the well count. But anyway, we choose well cost, and we're going to put $5,600 a month. And then we're also going to put another one for operating costs of oil of $1.50 per barrel. So you can apply that. Okay, so now that has been applied. That model has been applied to all the wells. So that's how easy it is to apply operating expense. All right, let's go on to the next part. And we're going to talk about product price schedules. If you're going to do an economic cash flow projection, you have to know what the price of oil and gas is going to be out in the future. So you have to build a schedule for the software to use. And PHDWin uses monthly price schedules. You can't put in a weekly price, so we just have to have an average for each month. You can build models and schedules, you know, for instance, an SEC is an average of 12 months, the last 12 months of prices. You can build a model like that in PHDWin if you want. Or you can build a model of flat prices. You know, for example, I just want to run my fuel reserves at $50 a barrel. You can do that. Or you can have a futures prices, and that's the futures market, and you'll have a different price each month out into the future. The market will tell you what oil is going to sell for, or what they think oil is going to sell for. So you can build a schedule with that. Or you can have a custom schedule. Say your client has an investment bank that's financing them, and the investment bank says, where our economics department says we want to use $50 oil in our reserve report for the first year, and $55 for the second year, and then $60 thereon. So if the client wants a custom model, you can do that also in PHDWin. All right, so let's see how we can do a price schedule or model in PHDWin. All right, so let's look at what we have. So right now on the prices tab, we have nothing. So let's turn off the evaluate and get all our wells in the list. So let's go ahead and apply a price to all the wells. You can easily just do it one at a time by clicking here and say pick model. Pick model here. And then your model file will pop up, and it'll show you all the oil schedules you've created. So you might want to use the NYMEX strip. You know, here's all the data from the NYMEX strip. You can do that one at a time. And, you know, apply it in there like that. You can also just, if you want, you can just take a well and just type in, you can say, I just want to run $50 oil. for the economic limit of that well. So that can be done without a model. The only problem is if you do that, you can't apply price differentials. And we're going to talk about price differentials later. But so if you want to have price differentials, you have to build a price model with your model file. All right, so another way you can apply prices is you can use the global editor. And you choose the wells you want to work on by dragging them in here, and you go to prices and you say apply model. Now we're going to apply a model for oil, a price model for oil. We're going to choose the different schedules we've created, and we're going to do it again for the gas. And then later we're going to do it for the NGLs if we have NGLs. So anyway, we're going to apply that to all the wells. Now we have a price for all the wells. So it's pretty simple. If you want to edit your model file, you can go to Editor Models. Or if you have a different model, you can change the link between your project and a different model. But if you want to just, say you want to add an SEC price for here's the SEC price for last year. Say you want to insert a new one, so you want to call it, you want to click on the gas and press insert, and you say this is the pay it forward gas model. So you say okay, and then there'd be nothing there, so you click on it, and you got some flexibility on how you set all this up. But you can say, well, gas is going to be $2.10, for 12 months. And then you hit insert again, and then you say, okay, then after 12 months, it's going to drop to $1.85. And then after that, it's going to drop to $1.75 until economic limit. Okay, so now you just made a gas model called PIF gas. So if you want that on this well, you just say pick model. And when it pops up, you pick this one and you just drag it in. Or you can do it as a global editor. So here's all your schedule. And if you want to check that in your sort order, you can just put the gas price in your sort order. Let's see how that works. Let's see what we have. We have to find gas price. I think that's under economics. So we can put gas price model. And we can save that as number 4 if we want to save that sort. All right, so it's gonna put the price model in the sort order so we can check them. Or you can do this in edit in Excel and look at them. All right, so all the wells have a NYMEX except that one. So you can easily check, okay, look, I got all the same prices for my field. So that's how you put a price schedule on the wells in PHDWin, so you can do all reserve projections. Okay, let's go back to our presentation. And like I said, we used the model file, and then we just edited it and applied it. And you can also, when you build a price schedule, include historical data. If you notice, the one I showed you had historical data in it, because sometimes you want to do a backdated cash flow run as a diagnostic test. So you have to have prices, in the previous history, maybe 2 years ago. So you can put them in the model file if you want also. But most of the time you just have future price. What's it going to be in the future? And there is a model editor module that PHDWin came out with that helps edit the models a little easier. I didn't show that, but I don't use it too much. And as I mentioned earlier, you can just specify the price. Like, I just want to put $50 oil without a model, and you just apply that number, but you can't have a differential if you do that. You only can have differentials when you have a price model. So what is a differential? A differential is the price. It's the price differentials are the differences between the price you receive for your oil or gas and the market price of the products at that time. So differentials can be positive or negative. And you calculate differentials every month. So differentials can be caused by crude oil quality, gas heating values, transportation charges, or local market conditions. So why they're important? Because the price that you receive for the product affects the cash flow and the economic limits and the reserve value. So if you're not getting the full market price, you have to account for that. And so as you model future prices, you have to adjust your forecast by these differentials. And I'll show you that. So how do you determine price differentials? The best way is to compare the historical revenue data to your historical market data. But sometimes you don't have that, and you may have a new well that has no history, and the operator says, well, we have a contract that we're going to get $1.50 over West Texas Intermediate. So you would just use that. And then sometimes you have to use public data or published reports, or in this basin we know they're getting this price, so you can use published data. So you have to come up with differentials some way. So the way I do it, the easiest way is to use historic data, and everything's based on monthly average dollars per barrel, because PHDWin uses monthly models. So here's a historical chart of West Texas Intermediate at Cushing, Oklahoma spot price averaged up for the month. So you have January through December and the price of oil in dollars per barrel. And you get this information from published industry sources. I use Ryder Scott. And you have to be consistent with, if you're choosing West Texas Intermediate for your historical prices, you have to use West Texas futures price in your economic projection. So you can't mix like South Louisiana Sweet historical prices and then use West Texas Intermediate for your forecast. So just be consistent. All right, so where do you get the futures price? Here's a sample of a website, and this is the NYMEX West Texas Intermediate from the CME group, and we pulled this data on February 3rd. So we call it a February 3rd strip. And what that means is you have the months out in the future here on the left, and then you have the trading volume, the amount of oil, the price of oil for the trade. But anyway, you have the last price out into the future. So this would be the price that the market says we're going to sell oil for. On February 2nd, we have this estimate of in the future. So you use these data to build your price model. All right, so here's an example where you can get pricing data from a check stub if you have it. So what can we learn? We have the name of the well right here. This is a check stub from a mineral owner. You have the name of the well, and you have all the months and all gas and NGLs, and it tells you their ownership share, so that can help you get ownership for this well, this pillow unit well. It also tells you the price of oil that they were getting in the field in June of 19, and it tells you the price of gas they're getting in the out there on this well. And then it also gives you the NGL volumes that they sold here, and then the price of NGLs in dollars per gallon. So this is a good source of historical data to help you come up with a price differential. All right, here's an example of an oil diff analysis. So what you do is you compile the sales amount of oil that the well produced each month or sold each month, and then you have the revenue from the revenue statement or check stub here in dollars. So you divide the revenue by the amount of oil sales and you get the oil price. So you do that each month. Then you take your historical market price that you pulled from industry sources or other sources, and you put it here, and then you just subtract 55 from 63, and you get a negative $8 a barrel. So differential is the price received minus the market price. So you can do that for each month, but I like to use the differential in a percentage. So you just take minus 8 divided by the market price. So that's a negative 12%. So you look at this each month to make sure it's consistent. Sometimes it changes. Like this looks like some bad data. I think I put in some bad data here. But anyway, you have to look at the different months. You need more than 1 month. You need several months to get a trend. And easy thing that you can start with is just take an average of all these. So you have to use your judgment. So in this case, the average is a negative 4.2% on the oil differential for this well that we're now analyzing. But you have to do this analysis for each well or reservoir or field as appropriate. If all the wells are in the same field and reservoir, you probably don't have to do this 100 times. You just do it for 1 or 2 wells in that field just to check it. But if several of the wells are in a different reservoir or in a different field, you have to do this calculation again. So you have to get differentials for each area and each well. All right, so let's recap. Price differentials are important for generating the future cash flow. So you have to be consistent with the source of the historical data in the market category you're using for the futures price. So you don't mix South Louisiana Sweet historical with West Texas Intermediate future. And price differentials are not always constant due to changing infrastructure and market conditions. For example, 2 years ago, the Permian had a big pipeline bottleneck, and the oil differential was very high for a while until they got new pipelines brought in. So you have to just use your judgment when you're doing your reserve projections. So you have to do oil differentials. I showed an example of that. But you also have to do gas differentials. And we'll talk about shrinkage later. And then if you're producing NGLs, you have to do the differentials on them also. All right, so let's look at our oil differential of negative 4.2% that we calculated, and let's go ahead and apply that to PHDWin so we can do the economics. So we go back to our PHDWin project, and we can pick a well, and okay, here's our oil schedule, for all the months that we built on this well. But you can see down here it says no oil diff. So if you want to press differentials, it'll pop up. Or you can just click on the word oil and it's going to pop up. So you can put a differential as a percent or as a dollars per barrel, or you can have a combination. I like to just use the percentage, minus 4.2. Remember, that's what we calculated. So you just apply that. Now it puts it down here and it changes the price up here. So this is the price in the first month after the as of date, because it took 4% off of the price in the model. So the price in the model for January of 2020 was 57, but it takes off 4% and it shows right here as 54. All right, so you can do that one at a time, or you can do it with the global editor function like we have seen several times in the past. So we're going to put this differential on all the wells. So we pick prices and we say change differential percent, and we're going to do oil, and we're going to put a minus 4.2, and we're going to apply that to all our wells. Okay, so now we have an oil differential on all the wells. And you can also, it's recalculating the price anyway. So what we need to do is we need to take off prices out of our sort order. So we'll just go to another sort order because that's slowing us down. Okay, you can also edit it in Excel. You can, pick some of the wells or all of the wells if you want to look at. Let's just look at these wells, and we're going to look at the price differentials. You choose price differentials, and you edit in Excel. And you can see right here, all the wells have the -4. If you want to change it, you can just, like if this well has a minus 8%, you can change it. Or if you know the gas differential is minus 10%, you put it there. All right, so you can change it there, or you can change it with the global editor, and you can say, yeah, bring it back. All right, so it's real easy to do. Now we have wells with production, we have a price, we have an operating expense, we have ownership, we have price differentials. And the next thing we want to look at is the NGL yield. So let's go back to our presentation. Okay, so we're going to talk about gas shrinkage and NGLs. Shrinkage is the difference between gas sales and reported production. And it could be due to fuel usage on the lease, or losses in the system, leaks, or mainly it's from gas processing. So if you process the gas to get NGLs, you're not going to sell as much gas as the well produced because it shrinks the gas going through the processing plant. So here's an example of calculating gas shrinkage. So you have a check stub that shows the sales of 417 MCF on this well. And we're assuming this is the gross sales, which may not be right. But anyway, And then you go to your production that was reported to the state for this well in the same month, and you have it in PHDWin so you can compare it. So the formula is just shrinkage is 1 minus the sales divided by production times 100, because we always use it as a whole number. So in this case, the shrinkage is 47% for this well. So you have to apply that to your economics. All right, how do you calculate NGL yield? So here, again, here's some sales volumes with the gallons of NGLs in August. And here's the production of gas in August. So the formula is, okay, you have to add up the two sales volumes. They had two different sales that month. And and you have to calculate the NGL yield, natural gas liquids yield. And we're going to use gallons. So we're going to take the NGL in gallons divided by the gas production in MCF. Sometimes people use barrels per million cubic feet, but PHDWin defaults to these units, so that's what I'm going to use. So when you do the calculation, the gallons divided by the MCF, you get 6.8 gallons per MCF. Okay, so let's apply our two numbers to our project.